It's now time for our panel discussion on hope, hype, and reality of big data analytics. The moderator for this discussion is Mohit Kumar from tech team at Flipkart. I'd like to invite on stage Mohit to introduce the panelist and kickstart the discussion. Over to you, Mohit.
Let's get started. Good evening, guys. Welcome. Wow, what a day. An amazing lead into the panel. Thanks, Anand, for such a wonderful talk. And calling out big data, big data, big data, big data, big data 5 times in your talk. That actually leads to very beautifully the panel topic that we have, which is exactly that, the hope, hype, and reality of big data analytics. There has been a lot of buzz around big data analytics. You know, it is one of the new buzzwords in the technology area, and as Anand rightly called out, and a lot of the panelists agree, and hopefully we'll get that out in the discussion, is what really is the hype part of it and what is the reality of it, right? We were doing just fine with DB2s, as Anand called out. So let's, with that intent, I would introduce the context of the panel. I'll introduce the panelists. The crux of the discussion is there has been immense progress. We heard in the first talk during the day by Dr. Ramesh from Strand Life Sciences, the real use cases where actually big data analytics has helped save lives, right? Now, that is the reality of some of it. He never took the word, never took the phrase big data analytics, but the kind of data that he was dealing with, the scale of data that he was dealing with in terms of the genetic modeling, the kind of techniques he was applying using large-scale NLP to filter out the literature review for finding the relevant genes is, in some sense, the true success stories of big data analytics, where you don't really take the name. Big data analytics is not the end goal. The end goal is really you're trying to solve a problem. So there have been success stories, but unfortunately there have been a lot of hype as well. One of the precedents of big data analytics challenges, one of the success stories that have been called out is the Netflix prize in 2007. Now, the prize was won in 2009, but really did it deliver on big data analytics? It took a merger of about 3 of the top data scientists across the globe to come up with the precision required to beat the prize. Unfortunately, the models that they developed were so complex, literally they kept putting in everything in that it was never deployed. So did it really succeed? Absolutely not. From a business perspective, it was a failure. Now, that's the intent of this talk, to go beyond the hype part. With that, let me introduce the esteemed panel that we have here. I'll start as in the order that we are sitting. Dr. Vivek Raghavan is the Chief Product Manager and Biometric Architect at UIDAI. He runs the Aadhaar program. He's a serial entrepreneur and an angel investor with experience with the Khosla Labs, focusing on Indian problems. He has built, run, and sold 2 startups in the EDA domain. He has a BTech from IIT Delhi and MS plus PhD from Carnegie Mellon University. With that, I'll request Dr. Raghavan to give his opening remarks.
So yeah, I think one of the requirements I said that when I would join this panel was to actually give an obligatory push for Aadhaar. So therefore, I'm going to talk a little bit about Aadhaar, and at least on the surface of it, it looks like it's big data, and then we'll go and we'll talk about as the panel comes, we'll talk about it. So I just want to at least just have a quick a couple of minute discussion about Aadhaar. So first, Aadhaar has, I don't know, most of you probably have gone through the Aadhaar enrollment. It actually collects a very small amount of demographic data, the name, the age, the gender, and a certain optional data such as the mobile number and the email address. And it collects some kinds of biometric data, which is a photograph, all 10 fingerprints, and both the irises. And the purpose really is to create a 12-digit number, which is a unique lifetime biometric identity. So is Aadhaar big data? Well, at least on the surface of it, we're close to generating 600 million Aadhars. Probably the next week we'll hit there. We process 1.5 million enrollments Aadhar each day. We've captured 8.5 billion biometrics of the residents of India. And we actually perform 900 trillion biometric person matches per day. We collect about 3 megabytes of data per resident. And we map to about 10 petabytes of raw data, which is all stored encrypted. And we do about 50 terabytes of I/O a day. And the additional processed data, every enrollment as it's processed actually goes through about a number of events as it gets processed, and we actually have 20 billion analytic records in our system. So at least on the surface of it, it seems like Aadhar is big data. Aadhar has a big ecosystem. So they have 50,000 enrollment stations, 100,000 operators, a bunch of agencies, registrars. So it's actually a very distributed ecosystem, not just a system which is focused on the back end of it, but it's a distributed system which is out there. And then the other thing that we do in Aadhar is authentication. And that's something that actually is the future. I think that's where we're moving. We actually our goal is to have 500 million people digitally assert their Aadhar identity in the next coming couple of years. And there, actually, it's a different problem that basically you go and you digitally assert. You give your Aadhar number and you give your biometrics, and the answer that comes back from Aadhar is yes or no. And this is a different kind of big data that's involved here. You have to be scaled for 100 million transactions per day. We are probably close to 500,000 today, but the goal is really to have a system that can handle 100 million transactions. And again, it's a huge ecosystem. We expect 3 to 5 million biometric devices across the country and thousands of agencies for different kinds of usages that would use Aadhar. So therefore, again, this is there is going to be a large amount of data in this ecosystem, which is of different nature. Similarly, if you have each authentication request is 4 kilobytes, we expect, so over a period, if you do 100 million authentications a day, you have 10 billion audit records, and that's a kind of so therefore, and then I think that's the essence that. On the surface of it, it looks like Aadhar and I think it is a fertile field for big data to be used in lots of things.
Sure. Thanks a lot, Vivek. Our next panelist is Dr. Sriram Raghavan from IBM India Research Lab. He's a senior technical staff member and manager of the Big Data Analytics Research Group at IBM, with interests in information retrieval, search, information extraction, and building platforms for big data analytics. He was previously at IBM Almaden Research Lab before moving to India. And he has a BTech from IIT Madras and PhD from Stanford. Shreya.
Thank you. So let me take a slightly different perspective. First, to the title of the panel, Hope, Hype, and Reality. I think there is all three. And at least over the last 5-6 years, I can think of examples where each of them apply. There have been projects that have promised hope, haven't delivered in the end. Netflix could fall in that category. There was a lot of hype, and I'll tell you some examples. But interestingly, we are seeing a lot of reality. And one of the advantages I have is, since I work in a research lab environment, I can afford to be a pure technologist and take the technology and apply it in many, many, many different industry contexts. So over the last 8 years, I've probably had the luxury of understanding what data and analytics mean in very different industries, from financial services companies or Wall Street types, which are bread and butter business for IBM, all the way down to talk about creaking technology. I'm talking about creaking industries, oil and gas, mining, farming, agriculture. And you will be amazed how much of big data and analytics is starting to show up in these industries. And there, I see real reality, because like with the point you made about genomics and life saying, there you talk about really making difference to things that we human beings can't survive without, energy and food and health and those kinds of topics. And it's happening because these are industries that are either waking up to the power of data-driven decision-making. These were industries living on gut. My surreal moment about 4 years back was talking to somebody who was responsible for asset management in a big oil and gas company. And at the end of 2 hours of very detailed discussion, when we ask him, what is your state of the art today, the guy turns back and says, gut. So how I do asset maintenance is gut. And we are trying to now revolutionize the industry and say, you don't have to do it with gut, you can do it with data. And trust me, in those industries, is massive amounts of data. It's massive amounts of data, sometimes in industries which can't even afford to ship the data. In an oil and gas industry, today, because of where they are in remote environments, their data shipping is not FTP, it's not HTTP, it's not any of those things. It is briefcases of hard disks that come back to a data center. But they are doing big data analytics because the impact is enormous. And that is, I think, is really revealing to me that we can affect very diverse industries. Another example that is something that I'm learning today is this whole notion of precision agriculture, where, again, mostly it was being gut. Now we are bringing in very fine-grained modeling, hydrology modeling, agricultural weather modeling, and so on, to really try and optimize what you can get of every little parcel of land. And that requires huge big data analytics. So in that sense, I think there is a lot of reality. Often the reality is hidden behind industries where clearly there is a lot more media attention. So it's a lot more interesting to write a media article about a company that's monitoring Twitter feeds to do social media sentiment analysis than to write about precision agriculture. But make no mistake, there is big data analytics and all of these things. And I think it's interesting to see that. I think in terms of why I believe that we will go beyond hype to get to reality, personally, I believe it is true because data-driven decision-making is here to stay. If I see 50, 100-year-old industries adopting it, I don't see any reason why data-driven decision-making will go away. That's number one. Number two is we are definitely moving to a world, we are already doing it, moving to a world where we have started instrumenting everything. So there is no paucity, there is no reason for anybody who wants to do data-driven decision-making to say, I don't have the data to do the decision. You have the data. Now, do you have the platforms, the infrastructure, the models, the analytics to pull insights out of it? That's where where the hype and reality separation will be. That's good.
Thanks, Sriram. Next is Sridhar Krishnan. He's the founder and CEO of Xurmo, which is a product R&D company in big data analytics space for hosting predictable self-learning applications. He's an entrepreneur with experience in a bunch of industry, including telecom and consumer marketing. He has a BTech from IIT Madras and an MBA from XLRI, Jamshedpur. Sridhar.
So thanks, Mohit. So propose of this topic, whether it's a hype or reality, as an entrepreneur in this space, you can guess what my answer is. So I bet, I have to bet on the side of reality. And there is a very fundamental reason why I think the whole concept of big data analytics is here to stay. I think the whole principle of the whole point is that over a period of time, as Sriram said, data-driven decisions will remove inefficiencies. And I don't think there is any part of human history which is negated an innovation that will bring more efficiency into the table. Having said that, so in the long run, yes, I think there is absolutely no doubt. For the reasons that both these gentlemen mentioned. Having said that, there is certainly a problem that we see in the short to medium term. I mean, this question cannot be posed without qualifying what is the time frame you're looking at for this, right? Is it a reality in the long term? Absolutely sure. But in the medium and short term, I don't think it is very easy to bring big data and analytics into the mainstream. And fundamentally, I think that there are three challenges that we face in this. One is the democratization of data itself. Who has access to data? We are digitizing the hell out of everything, but who has access to them is a very important question. The second thing is, once you have raw data, what do you do with it? How do you, the process of converting it into some kind of data product. That process is a closely guarded skill that belongs to a few people. That skill is not truly democratized. yet. And the third point is the democratization of ideas. For example, there's a lot of data getting collected in Aadhaar, and I'm sure that once you combine it with data from any other interaction we have with government agencies, you can really build beautiful e-governance products for citizenry. And I'm sure that's in the roadmap. But is that something that has caught popular imagination? I don't think so, and I think we are some distance away. It is still confined to a few people who have more intimate understanding of the data. That's my hypothesis. In the long run, it's a reality, but in the short term, I think we have to cross over certain challenges before it stops being a hype.
Sounds good. Thanks, Sridhar. With that, let me introduce our final panelists. Dr. Viral Shah is the co-creator of Circuit Space, which is an open source platform to help visualize large data sets, particularly about gene flows, genetic differentiations, something that Ramesh talked about, along with movement patterns of animals that is used in wildlife conservation. Along with that, he has also co-invented the Julia programming language, which is a technical computing language having a lot of features like inherent parallelization and distributed computing built in. He has a BTech from ITM and a PhD from UC Santa Barbara.
Sorry, I don't have a BTech from ITM. I think this seems to be some confusion, but that aside. So last few opening remarks, I guess all my colleagues have gone ahead. The project one of the projects I worked on, my thesis was Circuitscape, which is what Mohit just introduced, and I traditionally work in this field called scientific computing, and it's I don't know if it's big data, I don't know if it's analytics, but let me try to maybe define these terms for the rest of this this discussion from for my benefit. I like to think of something as big if the techniques or the hardware or the software today does not just work. I mean, if I can load something, Anand showed us a bunch of data that you can just load up stuff in Excel and do amazing stuff. I would say that's not big then. If anyone can do it, probably it should not be big. If it takes a significant amount of skill to do something, if it takes a significant amount of hardware, some of the stuff that you guys are doing out here at Flipkart, or my friend here Raghu who built the UID system, that required a lot of effort, doing stuff that's non-trivial. I think that qualifies as big. Or from my own experience of designing Circuitscape, now Circuitscape only runs on computers that are shared memory. It doesn't work in distributed memory. But it can consume gigabytes, hundreds of gigabytes of RAM. If you give it, it can solve larger problems. And over the last 10 years, well, seven years of its evolution, where a colleague of mine who's an ecologist who designed the mathematics behind it, who came up with the mathematics behind it, who could only solve it on a 100-node problem. And it used to take him almost a day to do that, to a point where today we can do problems that are of a size of 1 million or hundreds of millions of nodes within a matter of minutes or hours. It took considerable improvements in hardware, in memory, but also in algorithm design, in the programming languages that were used to implement the solution. So given the amount of time and effort and skill that was put in, I would say that it was a big problem. Although the data that it works on, by any definition of big data analytics, it's not consuming terabytes or petabytes. I mean, we only work on files that are gigabytes at most. But people run these things for days and use that to make decisions on where to spend hundreds of millions of dollars buying land for wildlife conservation. So I think with this, maybe with this background, maybe we can jump into the rest of the
Sounds great. Sounds great. So let me actually start the discussion part of it with a very controversial thing, or maybe diving deep into what truly is the hype, right? Why have there been failures? And if there have been failures. So if you guys can call out in your experiences, why there have been failures, why is anybody thinking that it is hype, it's not obviously reality. If you can share your thoughts, particularly around the failures, characterizing them, what are the kind of problems, what are be it technical problems, be it people challenges, as Sridhar, you were pointing out that it's a closely guarded skill. What are the characteristics that led to these failures, fueling the hype part of big data analytics? I'll start, Sridhar, with you, because you had already pointed that out.
I took that position, yes. No, I think in my experience, like I said, the problems are fundamentally three. And the most, what shall I say, the most exasperating of all, if you might call it, is the lack of an awareness of having a point of view on what is possible. So invariably, when I go and meet clients, there are obviously business leaders who are abreast of what's happening, but that point of view doesn't percolate across an organization. So you're talking about a 100,000 people company, and you want, when you want to have data-driven decision products to be made, you want ideas to come from various sources. And for that, people need to have a point of view on what is possible. And that is one big frustrating challenge, educating and evangelizing the possibilities of big data. That's number one. And that is a fairly universal phenomenon. I'm sure a lot of people have encountered that. The second challenge is a bigger challenge and a systemic challenge, in my opinion, is we all talk about capturing a lot of data. Who owns this data? If I truly want to create a hyper-personalized algorithm, which is or a product which is going to, I don't know, recommend or have a cognitive bot in your phone, which is actually going to take care of your calendar and stuff like that. It's possible. That's the promise of big data. But to do that, I need to have a comprehensive footprint of my user behavior in all various media, including Flipkart, so that I can use it in my modeling. Unfortunately, we don't have that. Data is in silos, and that is a systemic problem. I don't think there are any immediate solutions to this. I mean, WhatsApp sold for 19 billion. I mean, there is a reason, right? There is a huge amount of data captured. The third problem, which is, I think, the simplest of all three problems, is how do you convert raw data into a data product? The actual technology of it. You put it into a high-performance environment, a distributed computing environment. You create some algos. You do some visualization. To me, these are, as technologists, we believe that a technology problem is solvable. You can figure your way around it. And I think that's what a lot of people in this ecosystem are doing. And I think the technology problem, the technology solutions will be far outpacing the other two problems in this space. I think we'll be technology ready way before the world is going to be ready to share data and to construct data products.
But I would argue we are already there. I think technology has gone
absolutely,
ahead.
Yeah.
Another, I think I want to go back to the issue that the Sridhar mentioned about skill set. In my opinion, I think skilling, the availability of talent, and it is not about, it's not about, whether, how many people can you get with the word HBase in the resume or Elasticsearch in there. That's not it. I think it is people with practical hands-on experience in working with, large data sets or working with noisy data, working with text. There is a lot of intuition that you develop that I think the pool of people who have that is much smaller than the needs of the market or the needs of the hype that is servicing the market. And I think we see that, and personally I've been witness to projects which, in my opinion, met all the other bars for success. They chose the right problem. They had the data. We did not have the privacy challenges. There was no ownership issue. This was all within the enterprise. And the initial POC results were encouraging, indicative of potential success. But if I had to point to, there were many reasons for a failure, but I would say the biggest failure was the skill on the market to actually get it into a production deployed system. That is not available, and that is often underestimated. That's value.
Sure, but let me ask, the Netflix prize instance is a case where the skills were abundant.
Yes.
Those were the experts, yes. But still, it was fundamentally probably the wrong problem to dive in.
I agree.
Is that, are we seeing that percolating throughout the environment, that because of the hype, everybody thinks throw big data analytics at every problem and you'll get your solution?
And another reason, I think wrong problems are often chosen because I remember being in conversations where you go do your technology pitch, you talk about how big data analytics can revolutionize industry, and then we sat back and asked the people, say, what should be our starting use cases? I mean, I'm coming from a company, we want to pitch products or services. So we said, what's your starting use case? And often, and we are learning ourselves, but often the choice is made not based on whether this is the right problem to choose. Is this a scenario where signals from more data can be extracted and will have value? Often it is, let me scratch my head. What's the easiest amount of terabyte of data I can throw at this guy? He'll go away. We pick a problem, we run with it. And often that is because, as in large companies, there isn't a holistic picture. You talk to somebody, he in his domain thinks of his parcel where he has the biggest data. He believes, hey, these guys talking big data, let me throw it there. Often the ask is do something interesting. Yes, you could do something interesting, doesn't mean it's of value. And I think often that goes to a wrong choice of problem.
Sure. So I guess I'll let Vivek and Viral also jump in. Yeah. What are the fundamental failures if you have tried something in Aadhaar? And kind of, if you can get to, for the audience, the characterizations of the problem that would fundamentally lead to failure. For example, one of the use cases, let me seed the thoughts, was customer attrition modeling in the telecom industry. People started throwing in more and more data at it, but the needle did not budge. Human behavior is inherently unpredictable. There is only so much that you can do. So the incremental value that you get out of adding data is not that much, right? So it may fundamentally be a wrong problem for big data analytics. Analytics, yes. Incremental gain from big data analytics, not so much. Some examples where you've tried and failed, and I know it's a sensitive topic to call out, but I think that's of most value to the audience that, hey, yeah, we tried. I think that's the wrong problem to tackle.
No, I think first of all, I think, by definition, Aadhaar doesn't fail at anything. No, no. But I think the important thing is, and I think that's alluded to by these guys also, that you've got to figure out the right problem. And your Netflix example is the same way. I mean, it's if you don't actually select the right problem that you are trying to solve using big data. And actually, it is interesting. I think most analytic solutions, and again, I think going back to what Anand was also saying earlier, it is, somebody imagines something, they find something interesting to visualize, and that's the sale, right? That is that, you found something interesting based upon the data used. But that's not necessarily the problem the business is trying to solve. I mean, sometimes maybe it serendipitously helps you find some problem, okay, which is not, and I think that's where the difference in the hype is that, you're saying that I'm actually going to solve the most business critical problem using, analytics, while in the end, what happens is that most often of the time, the kind of problems that are identified are problems that are not necessarily obvious to the, and they may not be the most business critical.
Yes.
And I think the core. I mean, and I think that one of the things that in the design of the Aadhaar system, I think one of the things that we did was that we have certain benefits. We are talking mainly about structured data. We have ownership of most of the data. So we've kind of made sure that all the data that's there, okay, I mean, and that was the essential design was all the data that's there is available. Because if you don't have the data, obviously you can't solve the problem. But having said that the design was that way, we were not paranoid enough to find every kind of data that we needed to. And so when a specific business problem came, I think the issue became we actually don't have the data to try and solve that in an effective manner. And that's really, and I think that, especially in systems like where you actually do control all the data, actually not having some piece of data can actually be, it doesn't matter what analytic system you have, you're not going to be able to solve the problem. And, we had to go through, much more complicated ways of trying to solve the problem, as opposed to if, we actually had every piece of data. And I think that's, I mean, and that's you know, in many cases, many classes of problems, you don't have it. But even when you have it, it's a question. It may be in a silo, you may not be able to access it, or for some reason, a particular kind of data may not have been available, and you have to, and I think the issue is that, and that's a kind of area where I think that not having the data really impacts the solution.
Sure. So I think what you called out is from the failures perspective, people hope to find solutions once you have big data. I think that's what somewhat the hype is around, or the failures that we are seeing is around. This notion of the business folks that let's collect all the data and hope to find interesting problems. Along with visualization, at times you're not going in with an hypothesis, you see and you hope to find patterns. But again, it's the hope part that hopefully you'll find a pattern that you'd be able to define. Right?
And the point is that when the real business problem came, we had a lot of data, but we didn't have the data we needed.
Right. So again, the data gaps, there are well ill-defined problems, this hope of finding insights in a ton of data which does not exist.
And the quality of data often you have data, but its quality is highly questionable. And you often spend, in a big data analytics project, you may, and I remember, I think Anand mentioned a similar number somewhere in data preparation. His percentages are not far off. Yeah. Many data analytics projects spend more than 85% preparing their data, doing 10% of analytics. And often, you run into cost overruns and out of budget right there. So you don't even know whether the data had the insight. You don't even know whether you had the models. You are stuck with data preparation. So I think there is a lot of innovation opportunity in that space. Curation of data, the ability to apply interesting techniques to cleanse the data before we can apply analytics is probably going to have to be solved for these kinds of issues not to come.
Sure. But also, are we seeing a fundamental shift in, we've called out a lot of things that some of the patterns or the notions got skipped. For example, it was called out that in India, landlines were skipped. We went straight to cell phones. We are calling out, we are hoping that big box retail or organized retail is going to be skipped, and e-commerce will be the main pattern. Is a similar phenomena happening here in terms of the industries didn't really adopt analytics. They didn't really do any advanced analytics, any predictive modeling as such, but rather when this big data wave came around, they started collecting this data, and now probably once the reality dawns in, they would always be solving the big data analytics problems. Is that a fundamental shift that you are seeing? Viral, I'll start with you, and I think Sridhar, you had mentioned that there will be a shift. In the long run, we will see this happening. So yeah.
Yeah, I think, at least from my experience, and I've actually been to Flipkart, I've talked about Julia, I've actually talked about some of the problems with some of you folks here as well. I think, the way the hardware is going, the way distributed systems are growing, and the fact that storage is cheap, people just store all kinds of junk. Maybe we wouldn't have big data problems if we didn't store as much data, but that's maybe for a different day. I guess the idea is, store everything and then we'll figure out what we need at a later point, and that seems to be the way, the world is moving. The challenge is that's, the kind of skill required is just not there. Right? A person who looks at the data, right? A person who analyzes the data is traditionally not a computer scientist or a programmer. It's typically a statistician or maybe an experimentalist or someone who comes from from a domain, right? It could be a scientist, it could be an engineer. The person doesn't care about the latest tools that the computer scientists have come up with. On the other hand, you have computer scientists who are not trained in the discipline of kind of looking at data, thinking about it, thinking about what it has to say. I think recently on Twitter I saw a definition of a data scientist. I think let me try to recollect what it was. I think it said a data scientist is a person who can do better statistics than a programmer and can program better than any statistician. And I think it's a very apt, I think there is this sort of middle role that is emerging, and you have companies like Mu Sigma just trying to train hordes and hordes of people. You have more and more data coming, and I personally feel that the problem is not as much of skill or technologies, but but of the kinds of tools that people use to attack these problems. Right? That was one of the motivations for me to start working on Julia along with my colleagues. Of course, coming from a different background and a different standpoint, right? I mean, that was attacking technical or scientific computing, but I think the same issue remains. And I think as bigger, better, as better tools come along, you'll find that big data is not big or nasty anymore, and more and more people can do stuff.
I have an opinion on this, which is that if you see how most companies, and I'm not talking research labs, most commercial deployments of big data, what happens is that big data is treated as a bigger brother extension of OLAP, right? You have your Hadoop, you put all your data into HDFS, all that is fine, and then you say, okay, I have got my data in commodity servers, right? I've basically lowered the cost of storage. That's all I've done so far. But from that to insights, it's OLAP world. Now what do? You configure Hive or HBase or some NoSQL database, and you start with the problem definition. So you decide a priori, what is the kind of data I want to solve this problem. You look at the raw data in HDFS, you massage it, curate it. 80% of the time goes in putting it through Hive, and then you write your algo. The only divergence that happens, if at all it happens, is that from there onwards, one stream branches into your BI and visualization, which is a retrospective view of data, yes. And the other, which is a very small percentage, goes into analytics of a predictive or prescriptive nature. I think, given the kind of innovation that I am seeing in this space, including the kind of work that we do ourselves, I couldn't resist the little spiel there. What I see is that this OLAP model of applying those principles on big data is going to be given a huge go-by, which means that you will start seeing technologies which are going to bring more intuitive data cleansing, data preparation abilities. You're going to see, in fact, there are companies already, which I know, one company called KXN, which got acquired by SAP, I think a couple of years ago, which did recommendations on kind of algorithms. They're not extremely sophisticated yet, but the direction is there, which is how do I now start stating the problem that I want to solve and let the data speak for itself, rather than deciding a priori what do I want to do with raw data, do some massaging on it. So I think this whole OLAP approach to big data, I think it's a travesty, and it will deservedly be given a go-by.
So you're saying the problem definition is required. You need a very crystal clear problem definition.
Yes.
But the traditional world of ETL, the traditional world of transform,
yes,
load, understanding what the data means, the semantics of it,
yes,
is not as necessary to get to the insights.
Right. So and there are two parts to this. One is it is unfair and unrealistic to expect that you would have stated the right problem well. So here is a better way of doing things. State as many different ways in which you want to solve a problem, right? Create as many hypotheses as you want, but fail fast on them. Don't take 6 months to build one model and sample it out. Try to do it in 1 week, but in a given period of time, try to solve 100 hypotheses and figure out which one sticks, right? That could be a better way of doing things.
Sure. And you see, the challenges right now are more on why is this not happening already?
No, I think it's a question of there is a certain technology component as well here, which means that today if you see the entire Hadoop ecosystem is getting built around, and I'm not talking about the algo side, I'm talking about the processing side, data management layer, is a lot of inspiration is coming from the SQL world. in terms of the way you approach a problem, the inspiration is coming from there. I think that can be changed. For instance, one of the things that we do is to take a semantic web approach to data, where we don't do only schema on read on Hadoop. We also do schema on write, which makes the problem of data investigation, data integration so simple. We don't take a lot of time. And I'm sure those are the kind of new influences that can guide this process much better.
Sure. Sriram, do you agree?
No, and I do, and I wanted to go back to what you said about skipping. You asked specifically, I think, in an Indian context, like we did skip landlines, skip, and whether companies are doing that, and it's in fact happening. So there are many industries, banking being one, a couple of others, where companies that have not even invested in what you would call a traditional information architecture, ETL, data warehouse, who have not even done that, want to start doing analytics. So they basically said, so they are trying to basically say what was happening in mature markets in the last 15 years, I'm not even sure I want to do, but I want to do this new thing called analytics. And they are willing to explore new technology. So where in the mature markets, I'm talking to customers and telling them, here is your migration path from traditional SQL-based ecosystem to the big data, your traditional enterprise data warehouse to a big data warehouse. Many, not just India, many growth markets are saying, I don't have the last one. Build from scratch for me. This is the new world. I will just enter the new world. So it is in fact happening. Sure. And a lot of them are actually more receptive to radical approaches of the type Sridhar is talking to than mature markets, because in mature markets there is that mentality. I mean, that industry is whatever $20 billion data warehousing industry. So there are enough people who have seen value, who have seen every day morning their cognos or business objects reports, that they are seeped in there. So it's harder to tell them don't do that. So
the Accentures and the IBMs of the world have sold them their traditional data warehouses.
Yes,
it's
and
very
we have
tough
made our
for
money,
them.
no question about it.
We have tough for them.
And we will continue to make money on this migration path, no question about it.
Yes.
But I'm simply saying that in growth markets, you have the luxury of being a lot more radical, because there is a little bit more flexibility and not enough of that baggage, so to speak.
Sure, surely. And in terms of the success stories, you'd mentioned, you started mentioning some of those. If you can very quickly characterize, and we want to open the floor for a more interactive discussion in just a couple of minutes. If you can characterize what you see as they were successes because all these things lined up. For example, in genetic modeling, it was a scientific problem. It was a fairly straightforward target. All you needed was big data infrastructure to do all the high-level mappings and identify the genes. You needed large sets of data. Can you characterize, in your opinion, what are the things that are enabling success stories using big data analytics?
Okay, sure. So, I mean, I think some of the things that we succeeded quite well at was, when we were talking about really the quality of data that you collect. Now, when I say quality of biometric data as opposed to as well, but quality of biometric data that you collect. And this is something that's obviously, it's a very diverse ecosystem. There is data coming in from a large number of endpoints. There are a large number of reasons why there could be variations in the quality of data. And I think, including things like specific operators not being trained well, weather conditions, and actually we were able to identify a number and devices not working properly in the field. And it's actually been quite effective for us to point out the various sources of, basically either reasons for the quality of data not being good, and we were actually able to take various kinds of corrective actions to really understand and to maintain the quality of data that has been collected. And I think that's certainly been a success in the sense that it's given us actionable results, and we've actually been able to take corrective action for the business itself. And I think that's something that has been quite a big success for us.
I'd like to.
Go ahead.
Maybe, I think there are two ways to achieve success in big data. I'm going to give one answer in jest and maybe another, which may be a heretical suggestion here. But I think in many cases, you can just delete 99% of your data and work on the remaining 1%, and probably you'll find something which is pretty useful. Now, I mean, it may sound funny, but I think in many cases, if you just do the right kind of statistical sampling, you could actually come down to a data set which is meaningful to work with. May not always be the case, but I think in a large number of problems, you may get by. But this is one of the favorite things that I like to say to people, that just delete most of your data and you may actually get something out of it. But I think the real challenge on working with, if you have a genetic data set, right? I mean, well, actually 95% of it is unknown and junk, but keeping that aside. The real problem is that in most domains, there are no large open data sets. On our Julia mailing list, right, people keep asking, I want to do a regression on like some terabytes or petabytes of data. And you'll have someone who's asking, okay, give me a data set. And the guy's like, no, I can't share my data with you because it's all behind closed doors. So if you don't have open data sets that people will work with, how do you expect open source tools or anything else to catch up? There's so many academics sitting out there who would just love to solve all kinds of problems. I mean, the Netflix problem was just an example, right? I mean, it just showed the pent-up demand in the system of, if you just put something out there, there's like people waiting to just sit and figure it out. Sure. I think, if you have problems, try to remove most of your data, rather than publish open data sets. I think the same I would probably say about Flipkart. You guys have tons of data. Probably you can't release much of it, or probably 99% of it, but
there is two of us asking for data.
But it's actually interesting that you think there is a lot of data available in enterprises. A very different perspective is, I was at a conference, we had a discussion with a very top senior researcher from HP Labs. We had a discussion, we came aside, and he comes up and asks me, the talk was about big data. He says, do you have big data problems that you're working on? And I was at that time part of Accenture Labs. Accenture has tons of big clients. And I go, no, I only have small data that can fit in a traditional data warehouse. So there are only a handful of companies. Yes. Probably we can characterize them in the web domain that have tons of data, and some other domains that Sriram had started mentioning or mentioned in the oil and gas and those industries that have tons of data. But traditional, typical enterprises still are not there yet.
I have just to answer the same point that you raised. I think where we have seen things working is when the big data problem actually gets broken into two pieces. The first is the data collection and data agglomeration piece, which typically is done by the CIO and that office. And they're not really bothered looking at ROI on a byte level, right? They are more looking at infrastructure and getting all the data in. And they are open to the idea, provided the cost per terabyte is not very high, they're open to the idea of capturing more and more data sources and keeping it. The second piece is the decision sciences piece, which is, okay, now what are the specific problems I want to address? And there what we think it makes wonderful sense is to take an agile approach to that as well, where you actually sit with the customer and say, let's not try to boil the ocean. Let's take one small thing. Let me give you a heat map of your data, and then wow, this is great. Now, okay, now from this heat map, can we do the next thing? So, and it's a process of discovery for us and the client, and we both collaborate and figure out what are the various ways in which this problem can be built out. So
sure. Sounds good. Do you have anything to ask? We want to open the floor for questions. We have 5 to 10 minutes, so a couple of quick questions or some burning desires.
Hello. So Mohit was asking about characterizing a big data, the aspect when big data problem becomes successful. How important is infinite budget for that?
It never hurts, for sure. It doesn't hurt. Actually, keeping jokes aside, I think the successful projects I have seen are the ones that put technology the last. The successful ones were where Data quality was not an issue. Data availability was not an issue. The clear conception of, you do this for me, it means this many dollars for me. When none of that in question, then you come and solve the technology problem. You can almost always solve the technology problem. And you don't need infinite budget.
Yes.
But I think it's when you put the cart before the horse that you get all the mistaken big, which is, I want a successful big data project. I don't even know what I want to do, but I want a successful big data project. Then you put technology first, and then you put the business
Right.
first.
That's what my CIO or CEO was asking, that he heard at the Gartner conference about this big data buzzword. What are we doing about it?
Checkbox.
Exactly.
I mean, there was an unstated glee that, we are skipping certain stages of evolution. Like we said that, we will not have big box retail, but we'll move to e-commerce, or, in telecom, we had more mobiles than landlines and things like that. Now, the danger of that kind of approach, I think, is we'll fundamentally be losing out on innovation completely. Okay, if you take the mobile penetration in India, it was more a business model innovation than a technology innovation. Okay, so is that a thought that we should perpetuate, or should we do something else to change fundamental? Like, for example, can the next Hadoop come from, let's say, India? Is that a possibility, or will we be continuously, be susceptible to this kind of a dependency and move more and more towards services?
No, I think these are two different paradigms. When you talk about skipping a generation, you're talking about skipping a generation vis-a-vis what happened in another country or in another society some time ago, right? This, unfortunately, is a level playing field for everybody. So when we are talking about skipping a generation in the big data space, we are not necessarily compromising on innovation, because here, unlike in the mobile phone case where you can just ship some handsets made in some place and ship it at dirt cheap price, here you have to fundamentally solve some technology issues before you can skip a generation. And I think that innovation is happening here a lot in Bangalore. And for instance, we are doing a lot of work in this space. There are a lot of colleagues I know in various startups who are tackling various different pieces of the puzzle. So I think there is a definite technology component to skipping this generation thing. And I think it's a level playing field where innovators from across the world are equally contributing, though there is a certain preference to people from Silicon Valley.
And I would add that, in fact, I think the skipping piece has a couple of dimensions to it. One is you skip maybe because you believe, look, they have learned something. Looks like they are moving on. I'm going to take that learning and adapt it. But often it requires, in fact, even more innovation, because what you're simply saying is, as I said before, there is actually, you have the luxury of applying even more innovation in some of these markets than in the mature markets, because you have less baggage to deal with. You have more receptive people who are willing to try out new things, who don't ask the question, but this is not what we did 4 years ago, because they did nothing 4 years ago. So this is brand new level playing field. So in fact, I would argue, depending on what the industry is, that there may actually be value to starting on a clean slate and being able to innovate.
I would say that leapfrogging has nothing to do with innovation. Finally, to innovate, you need to stand on the shoulders of giants, right? I mean, the famous statement every one of us knows. I think it's important to leapfrog so that we catch up and then we sort of go forward. Otherwise, we'll always be sort of, trying to catch up. I mean,
and the leapfrogging is somewhat happening in industries who have not deployed the traditional architectures, the traditional intelligence as such. So it's not just geography specific or domain specifics. It's about the industries, and so on and so forth. So it has, as pointed out, multiple dimensions to the leapfrogging as such. Sure.
The panel talked about democratization of data and analytics over it. But then panel also talked about technology should come last. How does these two pan out?
For you to have a successful big data project, if you start with the technology, you often end up wrong. You start with the business problem, work your way back. And when you get to the technology problem, then you need the skills of the people on the ground to be able to solve the problem. So they are not conflicting, at least the way I see that.
So the end goal is not to deploy a Hadoop cluster, but to solve a business problem.
Exactly. But if Hadoop is the answer, you do need people with the skills to deploy Hadoop.
Yeah, and if you choose Hadoop, you need the
Exactly.
But wouldn't in an organization that is something like Flipkart, which is an e-commerce organization, wouldn't publishing the data or coming up with a platform where you publish data and make it available for everybody is a priority, along with building up skill sets for solving specific business problems? Because once there can be another angle to the whole ecosystem is that once you have accumulated, a curated or quality set of data, which I totally agree with, and which can lead to interesting solutions or interesting initiatives in other teams. What I mean to say is that wouldn't the technology and the business problems go hand in hand? Basically, you have to have a technology that gives you quality data, then you can have a business leveraging that data, and then that is requiring more technology to be built alongside it.
Yeah, I tend to agree with you, and that's what I mentioned earlier when I said that segregation of the big data problem into two pieces. The first part is it doesn't cost much to store data, so might as well capture it. Don't capture data opportunistically. Store it, keep it, make it available in a cheap manner so that it can be accessed if and when required. And then comes the second piece of what do you do with the data, which is where the idea is that don't buy the most expensive algo libraries or high performance machines which can do a lot of in-memory processing. Wait, get your business problem right. Then we will talk about all that.
Okay, so I have another question that is to Sridhar regarding you're talking about OLAP and that it is going to be redundant.
I didn't say that.
Huh?
I didn't say that.
Okay.
I didn't say it's redundant.
Okay, so what are the other tools that will be available or that is right now available for exploring data? OLAP has been, or the cubing model or the dimension model has been the traditional way to explore data set, coming out with more and more new metrics.
Right.
What do you think if that goes away or that people choose to bypass it? What will be the other ways to explore data?
So the approach that we take is a more semantic web approach where we don't rely on a problem-specific schema to be loaded in a cube and then you do querying. Because the fundamental premise of that model is that you have already decided the features or the subset of features that you want to play with, right? You have not left any room for serendipity. But that's the whole point of big data. You don't know where data lies, and you don't know what is a magic that is missing because you didn't think about it. So where we have found great value is, RDF is very tough to implement. So we're not saying go and create RDF tuples. But there is an inspiration that can be done, that can be taken from the principles that have defined RDF, which is you put in data that comes in some schema that is semantified, so that no data is escaping the radar, right? Once you have got whatever data comes in and it is reasonably semantified, then your exploration becomes easy. You can actually explore. So we always emphasize on the difference between search and query, where search is actually an exploration operation. Query is a very deterministic operation. You know there is data, you're asking the guy to give you the data, right? Now if you're able to combine both, where you are able to search or explore like search, but put enough intelligence in the machine or in the system to interpret and give you back data that it thinks is relevant, or the subset of data that it thinks is relevant. Now that is the basic construct of the semantic web query. So if you do that, this 80% data preparation time can be dramatically reduced. It can be actually democratized. You don't need to know HiveQL and whatnot to play around with the data. You can start interrogating data very rapidly. That's just that's an approach. I'm sure there are many others.
Sure. Sounds good.
Time up, Mohit.
Yeah. With that, I'd like to thank the panelists so much thank you so much for taking the time out to join us. And thanks a lot.
Thanks to Mohit and all of the panelists for that interesting discussion. I'd like to invite back on stage Amod for the closing note.
Yeah, so recognizing the end of the evening, I'll keep it very short. I hope you guys had a great day and plenty of learnings. Thank you so much for coming over. And I'm hoping I'll be seeing you guys again in the next event of /N next year. I thank all the folks who ended up taking the time out, our panelists, all the external speakers, our internal speakers who ended up putting a lot of effort in making this a grand success. Thank you so much. And of course, you, the participants, thanks again. Have a good day.
Thanks, Amod. And with that, ladies and gentlemen, we have come to the end of the talks for /N 2014. We hope you enjoyed this as much as we enjoyed putting it together for you. Thank you so much for making /N a success.